This time, let us have a look at the curve y is equal to x cubed. So, if we want to look at this area, this time, we want to find the area between the x-axis, between the curve, the x-axis, and negative 1 to 0. So, we're looking from negative 1 here to 0. So, this is the area in here we want to find. So, if we do our integration, we know negative 1 to 0 of x cubed, where we add 1 to the power, divide by the power, so it gives us x power 4 over 4. Substitute 0, substitute minus 1 in. That would give us a positive because it's an even power, but then the negative gives us a negative a quarter. Hopefully the alarm bells are ringing because we did say area, and we've got negative a quarter, and we know that we can't take a negative answer because it's an area. So what can we do? Well, we do know that that's actually a value. We've done the definite integral of negative 1 to 0 of x cubed. Now, definite integral, we know we can get a negative answer, and that's okay if it's a definite integral. But if we're going to start applying it to an area type situation, we've got to have some limits on what we can take, and that means that if it's an area below the x-axis, it's going to give us a negative. We just need to take the absolute value because we're not considering its direction because it's below the x-axis. We're just considering its magnitude, its size. So anything above the x-axis is going to give us a positive answer. Anything below the x-axis is going to give a negative answer when we take a definite integral of it. So we've just got to make sure we go, okay, it's an area question. If it's giving a negative because it's below the x-axis, then we take the absolute value because we just want to consider its size. We don't want to consider its direction. So it's important to realize, and this is where we want to start drawing graphs up, to realize where it's actually going to be below the x-axis so we can go, okay, don't start doing some negatives there, just make it sure we take the positives and take the absolute value there. So that's the only thing we need to make sure we do is take the absolute value of the result and be aware of it. So if you have a look in this is one where if we try and do it straight out, we won't get a correct area because, again, x cubed, because it's a classic case of an odd function as such, and we're going between negative 1 and 1. So there's our shaded areas that we want to find. And if we integrate that, we'll see that we get a quarter minus a quarter, which is going to give us 0. So that's the problem there. So what we really need to do is split it up and say, well, let's look at that area between negative 1 and 0, and then look at that one between 0 and 1. Well, that's going to be fine, so that's going to be a positive a quarter. That one's going to end up being a negative a quarter because it's in the negative direction. So let's take the absolute value. It should give us a half. As you can see, like if we do the definite integral, the computer program I use for the graphing does that for me. Says that, well, the definite integral is 0, but if I want to find the area, it's a half, so I don't know what the 0.30003 is there. But the area is 0.5 if we're taking that application of our integration. So the other way to do this is to realize that it is an odd function, and double the area of 0 to 1 of x cubed. That's fine because we can see it's exactly the same area, but because it's been negative 1 to 1. And so just go from 0 to 1 and double it, and that's going to give you the half again. So just be wary that you're going to have situations where anything's below the x-axis starts to be having to take an absolute value, and need to do some splitting up of our integration.